All right, today we are talking about solving compound inequalities. We've spent the last 3 to 4 days just solving inequalities, correct? Yes? Okay. So the only difference on today's is we have two inequalities on one problem, and we're going to graph both of those inequalities on the same graph, okay? So that's really the only new thing that we're doing today, all right? So here's first thing we need to know about compound inequalities, okay? Yes. So when we use a compound inequality, they use an and or statement.
And or what?
And or. Like statements and or it's an or statement. Now, when we have an and statement and when we have an or statement, kind of drives what happens with our graph, okay? So, if your mom tells you you have to take out the trash and do the dishes, what is expected of you? Both things, right? So when I have an and statement, both have to be true. And we'll kind of talk through what that means as we go through some of these examples about both being true. But in two separate things, whatever you're choosing has to work for both, okay? What if your mom says, take out the trash or do the dishes? Yeah, as long as one of them works, then you're okay. So on an or statement, either can be true. So either case will work. So or there's a lot more room to work with. An and statement, a little less room to work with. Okay, but it's pretty self-explanatory. Okay, we okay on this? Yeah. All right. Okay, first thing they're going to do is they're going to ask us to graph b is greater than 3 or b is less than or equal to 0. So first thing we want to do is just put a number line on our paper. You guys can go ahead and write that down. B is greater than 3 or b is less than or equal to 0. And then we just need a number line. Now, we are on Alex today, so it'll give you all these number lines. So all you're going to have to do is put the graph on there. I'm trying to make it a little simpler for you, okay? Now, essentially, all you have to do is just graph each inequality, okay? Now, we do want to check some things and make sure it works, but how would I graph b greater than 3?
3 with an
Open circle, good, at 3. Going what direction?
Right.
To the right, because I want any number that's greater than 3. Then how can I graph b is less than or equal to 0? Tallulah?
Just kidding.
What'd you say? Oh, you were whispering something. Filled in circle at what number?
0.
At 0. And if I want less than 0, what direction's that arrow going?
Left.
To the left. Okay, so I have just shown that b can be greater than 3 or b can be less than or equal to 0. So if I said, right, Kaylin, give me any number that's either greater than 3 or less than or equal to 0.
1.
That would literally be one of the only choices you can't have.
It's greater.
Yeah, just pick any number that's either greater than 3 or less than or equal to 0.
4.
4, right? So, hey, listen to me. 4 works because 4 is what? Greater than 3. And this is an or statement, so it only has to work for one of them, okay? What if Chisholm, instead of saying 1, chose negative 1?
I said that. I did not say that.
Would negative 1 work?
Yeah.
Yeah, because negative 1 is less than or equal to 0. And it's an or statement, so as long as it's true for one of them, then you're okay. All right? So far, okay? Now, what are the only two numbers, well, three numbers, you cannot choose here?
1, 2, and
3.
0.
1, 2, and 3, right? I can't choose 1, 2, or 3 because 3 has an open circle, okay? Those are literally the only three numbers we can't choose, or any decimal between, but we're not really talking about decimals, okay? All right, next one. Same thing, we're going to graph these two. What type of statement is given on these two inequalities? And. So this one, when we graph, it has to work for both, okay? It has to be true for both.
So like on these ones where you're graphing, will it also ask you like answer like for?
No, I'm just asking you so you guys kind of get an idea on how to know if you're getting the right answer, okay? All right, so on this, the first one I'm graphing is what? What's the first one that it gives you? Air day.
That one.
What's it say?
Does it 7 or Z?
Z.
Oh, Z is less than or equal to 3.
Okay, how do you graph Z is less than or equal to 3? What type of circle?
Close.
Closed, and less than or equal to would go which direction? Left. So at 3, it's going this way. I'm just going to go a little bit and then stop, okay? Chisholm, what about Z greater than or equal to -2? What type of circle?
It would be a closed circle,
At -2, greater than or equal will go which direction?
right?
Okay?
So now what?
So that's your graph. So essentially, right, because if I said pick any number that is less than or equal to 3, but it also has to be greater than or equal to 2, what are our choices?
All the ones in the red.
Yeah, anything between -2 and 3, right? Is 0 less than or equal to 3?
Yeah.
Yes. Is 0 also greater than or equal to -2?
Yeah.
Yes. So that's why anything between those 2 points work. Okay? Now, could you choose 5 as a value?
No.
But 5 is greater than or equal to -2,
But it's
But
not.
it's not.
but it's not also less than 3. Okay? So that's where the and statement comes in. It has to be true for both. Does everybody see the difference between and or? Okay? Now, typically, here's what I told my other class today. Typically, this is what a graph of an or statement looks like, and this is what an and statement looks like. Are they always going to be this way?
No.
No. There are some variations, and you're going to see those today. I'm going to try to show you some before we're done. But most of the time, that's what you're going to see. Okay? All right. Next one. This one gives you a graph and asks you to write a compound inequality that is shown by the graph here. Okay? So we're going to write the first inequality, this one on the left. We're going to decide if it's and or, and then we're going to write this inequality on the right. So can anyone tell me what inequality I would write for the one on the left?
X is less than -1.
Very good. X is less than -1. Open circle, so we don't include the equal sign, and it's at -1. Would this be an and or graph? Or, because they're going away from each other. On the ones where you guys are writing your own, they will always look like this, okay? When it gives you a graph, you're going to know. All right? Okay? And then somebody else tell me what would be the last inequality here.
X is greater than 2.
Perfect. Good. X is less than -1, or X is greater than +2. Okay? Not too bad? Okay, here's your second one. I'll give you guys a second to write this down, those of you that are putting this on your paper. Open circle at -3, closed circle at +3. Everything between is being shaded. Anybody want to take this one?
Already does.
Anybody that hadn't gone yet?
Hey, you didn't want to know it's done.
I already went. Doesn't already. I think you forgot.
Would it be like X is, let's say, greater than -3?
Okay, good. X is greater than negative 3 because we're going to the right.
And X is less than or equal to
Perfect. Yeah. Now, I am going to tell you on this, everybody needs to watch this. There are some times where they want you to write an and statement using only one variable, okay? In that case, X goes in the middle. On this one, the mouth is open to where?
X.
The mouth is open to X, so I'm going to leave the mouth open to X and put negative 3 on this side. Here, I can bring this exactly down how I see it. X
I do not
less than or equal to 3. Okay? Because I wrote X is greater than negative 3, so if I put X on this side, the greater than has to be still pointing towards
Still wants
X.
X from dinner.
Okay? Yes? All right. A couple more. We're getting close to being done. Okay? All right. Here, they do want us to graph. But before I graph, what do I have to do to each inequality?
So,
Solve for
and
m. Okay?
boom.
So we have 22 is greater than or equal to 4m minus 2. Or 5 minus 3m is less than or equal to negative 13.
Do you do both of them?
We are going to do both of them, yeah. Harper, will you tell me how to solve the one on the left?
You would plus 2 to 22.
Okay, so I get 24 is greater than or equal to 4m. And then what's your last step, Harper?
Divide each other.
Good. So we get 6 is greater than or equal to m. Now, if I'm going to graph this, what would be a better way to write that out?
By the way,
is less than equal to
M is less than or equal to 6. Okay? All right. Aiden, will you do the other one for me?
two plus 5 or minus 5.
Minus 5, yeah. So we get negative 3m less than or equal to what? Negative 18. Okay, last step.
Divided by -3.
Now I just divided both sides by a negative. What do I need to remember to do?
flip the inequality.
Flip that inequality. So m is greater than or equal to 6. Okay? Now, I have an or statement, right? So as long either one can be true, what's this going to look like on my graph?
Them going away from each other.
So they're both starting at 6, right? Do they both include 6 though?
No, they go away from each other.
Right, but do both points include 6? Yes. So really, on your graph, it's going to look like this.
It's the whole thing. Holy moly.
So on Alex, if you got one like this, you would just click the line. You don't need to put any points on there because this includes all numbers. Okay? Because you can choose anything less than or equal to 6 or anything greater than or equal to 6.
So funny here?
Okay? Everybody okay here? All right. We're getting close. These will go quick because they're just like quick examples that I want to show you for when you see this. Okay? All right. What type of statement is given here? And. Okay? So let's just say I go to graph this first one. How would I graph x less than 3?
Open circle left.
Open circle going to the left, right? Would look like this. How would I graph x is greater than 5?
Open circle right.
Okay? You do this, you click check on Alex, it's going to tell you incorrect. Why?
Because there's like no number that you can pick that is that there's not enough
Because Alex is
of them.
mean.
Yeah. So what Kaylin's trying to say is there's not a number that works for both, correct?
Struggle.
Can anyone tell me a number that is less than 3 and also greater than 5?
8.
8's greater than 5, but it's not less than 3.
None.
There is none, right? So what should you choose for your answer here? No solution is correct. Okay? So you have to be careful on that. And this is why I kind of make you guys do this. I make you draw it out, but then you need to look at it and say, okay, well, what number works for both of these things? Well, there is none, so no solution. Okay? Let's look at this next one.
Yeah.
Now, listen, you ain't even having to write anything down, sir.
Right through.
Okay, tell me how to graph the first one, Chisholm.
You put.
What type of circle?
Open.
At what number?
3.
Going what direction?
Right.
Okay. What about graphing the second one?
At 5.
What circle?
No, going right.
Open, also going right. Now, here's where you have to be careful, okay? On the graph, you cannot have this open circle here, right? Because it's an or statement. So when I say I want anything greater than 3, does that include 5? Yeah. So I don't even need this here. You would essentially erase that circle, and it would just look like this. Okay? Now, last one, and then I'm going to let you go. Okay? I'm going to give the exact same numbers. X greater than 3, but I'm going to put and x greater than 5.
It's the same thing.
The last one was an or statement.
Oh.
Okay? So, here's what I want you to think about. What numbers are both bigger than 3 and bigger than 5?
6, 7, 8.
6, 7, 8. So, which is the only one I'll graph here?
5.
So, what type of circle?
Open circle.
Open circle at 5, going to the right. Okay? Notice on an and statement, it's the exact same problem I did with an or statement, but the and has to include both numbers, so I just start at 5 only. Do we see the difference on those two things? Does that make sense? Really, you guys, I think a lot of this stuff we're good with. We just get to the graphing sometimes, and when you don't pay attention to if it's and or and where to graph, that sometimes trips us up. Okay? All right. Alex today.